Owais has completed his MS in computer science with the University of California. One important point to sort of keep in mind here is that he was on a full scholarship there, which essentially also tells you, for those of you who are planning to go for higher studies, that these are possibilities that one should explore. Before that, he obtained a bachelor's in computer science from Osmania University, Muhammad College in particular. So, OS, it's, I guess over to you, and you would want to introduce Mustafa also, because he's going to
Yes,
be
Professor
with.
Ansari, thank you so much for that kind introduction. And before I get started, what I'll do is I'll introduce Mujtaba Bhai. He's a data scientist at Amazon Web Services. He's a data science and analytics professional. He currently advises executive decisions through data-driven insights at AWS. And prior to Amazon, Mujtaba Bhai also worked at ZS Associates and Accenture. He has worked across supply chain, technology, logistics, and strategy domains. He's currently based out of Hyderabad and also a graduate of Mufakhamja College of Engineering and Technology. He was my senior both at college as well as right now at Amazon. So glad to have Mujtaba Bhai on the call as well. He'll be managing the questions via chat. So what I'd recommend each and every one of you is to be interactive and ask any questions that you might have, however simple they may be. And we both will try to answer them for you. Mujtaba Bhai will be managing that via the chat. So with that, let me go ahead and start sharing my presentation and starting the session. So can somebody confirm if my screen is visible on the share screen mode right now?
Yep.
Yes, it is.
Yes.
Great. Thank you. So it's good to see a large group of folks here. It must be late at Hyderabad, so we try to make this as much fun as possible. So the session is basically technical skills in data science. It's our first technical session on data science by the SETI Foundation um, in 2021. So what I will be providing you is an overview of what sort of data science is, what are the skills needed to become a data science, what are the sort of applications that are available in data science, along with how you could get started. So some fun facts about data science. And what I do is I'll just put this on the screen and let you guys read along with me reading it. As you can see that there's only 0.5% of the data that we've been creating as humans is being analyzed and used. And it is believed that about 2.5 quintillion bytes, which is a million terabytes of data, is being produced every day. And this is increasing quite a bit. And 90% of which was collected over the last 5 years. And it's been estimated that about 10% increase in the accessibility of this data will generate more than about $65 million in net income for any typical sort of Fortune 500 company. And then finally, by about 2025, the data science and analytics sector in India is estimated to grow 8-fold, reaching about $16 billion. So what this does is it just sets the foundation that this is an important, exciting area where there's a lot of opportunity. So with that, let's move into what exactly is data science. So what you see here are a couple of memes and comics. And what you see here is probably not what we are actually doing as data scientists, but this is kind of how it might be perceived because we're working with a lot of data. But moving on to what actually is data science beyond what we see here. So data science is basically, it's the process by which we use data to solve problems in the real world. The idea here is that there's a lot of data that's being generated by companies across various industries, and there are a lot of problems that they're trying to solve. And how do we use that data to solve those problems? And then within that, machine learning is basically based on the standard definition that you see here. It's the ability that we're giving computers to be able to solve these problems or learn from this data without being explicitly programmed. A lot of you must be computer science students who are programming where you specifically set if and else conditions based on specific criteria. But when it comes to machine learning, what you're doing is you're simply providing the algorithm the data, and it's learning by itself what it means and is able to make the predictions accordingly. So why are these fields growing? Quite a bit. I'm sure you might have heard a lot more of this over the last couple of years or last 5 years. And the reasons are that because of the large quantities of data that we're working with, along with the significant advances that you guys might be observing in computing. So how does that sort of translate to the evolution of statistics to machine learning? This is basically based on the 4 V's of data science. So what you see here is volume, variety, velocity, and veracity. Back in the day, in the 80s and 70s, what used to be called statistics is now being considered as machine learning. And these are primarily the 4 reasons why it's moved this way, and it's gained quite a bit of momentum. The first is basically volume, which is size and scalability. You guys must be using social media and various platforms. Facebook and Twitter, they've got daily activity of hundreds of millions of users who generate a lot of content based on text data, image data, video content. Netflix, for example, a streaming service, has 182 million subscribers, and the amount of data that they're generating on a daily basis is very useful in driving what they should recommend to other customers. Along with that, there's been a significant variety of data, which is how it is being captured and stored these days. You see text data, you've got numbers, audio, images, clickstream. And then the next thing is the velocity of data. These days, data is being generated rapidly. Every hour, I'm sure you must see a million tweets that are being published. And this streaming data needs to be processed on a continuous basis to understand the trends. And this is how it is working out. And then finally, how important it is to have veracity, which is how accurate and applicable this data is. So these are the 4 primary V's that we have for data science. So now I'd say, why should you care? You're a student who's probably in your 3rd year, in your 4th year, and at the cusp of deciding basically where you want to go in life. Now, you've got 2 parts primarily. One is sort of software engineering. Another one is a divergent field, which could be data science, cloud computing, etc. When it comes to data science in particular, I would say it's important because you now will have the opportunity to basically solve some of the most important problems across various fields, which may be tech consulting, healthcare, and finance. And along with that, you wouldn't be working just on projects and coding and programming. What you're going to be doing is you'll be working closely with the business and understanding what their problems are and trying to strategize and help them grow their company better or direct their customers better. So it's a combination of working with the business as well as technology. And then finally, it's a rapidly growing field. And if you just search Naukri.com as of today, you'll see that there are over 50,000 jobs available. So there's a lot of opportunity available right now, along with it's one of the better paying jobs. So you'll not only be able to work on interesting things, but also be able to earn well. So with that, what I'm going to do is start opening it up to the group. This is going to be a frequent pattern in our discussion where we'll have small breaks for questions that you might have. And I'm sure each and every one of you must have thought about data science. You might have questions around what it fundamentally means, how it could be used, what are sort of the ways in which you could achieve specific goals in learning data science. So what I would encourage you to do is to make this more interactive, where just open the chat box and you can ask the most simplest question and we'll pick it up and answer them for you. And we'll keep doing this every now and then so that it helps drive a conversation between both of us. So with that, I see a couple of chat already coming up. So the question from Abinuddin, is there a specific discussion for computer science? Yes, we have a session that's lined up for tomorrow that is on computer science. Now, a question that
just one
yes,
second, sorry. The question
sure.
from Mubinuddin was that is data science only relevant for computer science, or can anyone else play in the field?
Sure. That's a good question to ask, and thank you for clarifying, Professor Ansari. It's actually a field that is applicable for folks across the board. Somebody who's in healthcare wants to understand their data better. They can very quickly be able to understand fundamental statistics along with a bit of machine learning and be able to start processing their data in a much better way than before. It's applicable to, for example, forecasting in COVID-19, epidemiologists and biostatisticians who are working in it who are in the healthcare field. So it is applicable to folks a lot beyond computer science, even within engineering fields as well. There are many students who could be in electrical, electronics and communications, mechanical, who will have applications for data science. So the next question by Arshad, which is sort of Python versus Java, which one is the better to get hands dirty for data science? I would say you could start with Python because of its libraries that are available. I think that would be very useful for you to be able to get your hands dirty and start working right away. It's a lot more flexible as well as it's comfortable to use. I primarily use Python on my daily basis, so we'll be talking a bit more about the languages as well and getting into a bit more detail, Arshad. The next question by Majid, can you describe how we are using data science? So that's a good question, and that's one of the things that is going to come up right away, which we'll be discussing applications of data science across various industries. So great questions, guys. How to get hands-on experience of data science projects so that we can understand how and what we have to do at data science job. So for this in particular, I would say that a simple resource that you could use is a website called Kaggle, Kaggle, on which there are competitions across various data sets, along with solutions that are provided by many folks on how to develop the most optimal way of solving that problem. So I would say is that you could get started with that, develop your own solution, and then compare it with other solutions available, and gradually you'll learn to do better. And those projects could be added to your resume. Shahir, the programming language on which a data science works or any other programming language. So I would say this, there are a variety of languages that folks use, which include Python as well as R, which is a statistical programming language. However, I would recommend you pick one of these and then develop your skill in it. In Python. So how much coding centric is data science? You would have to know how to code, be it R or Python. So it is essential that you know how to code, but there are tools available where you could develop regression models or other machine learning models using drag and drop solutions as well. So you might be able to develop it without coding. However, the most optimal solutions or the most efficient ones that you could build will require coding. So let's take a couple of more questions and then move on to the rest of the session and then pick them up again. So I'm very glad to see a whole bunch of questions coming in, and Mustafa Bhai also is providing a whole lot of great answers. So please do read them as well. Is there an occupation within data science where hands-on coding is not required, rather data management and so on? So I suppose there are certain roles that are available within data science, which include business and prior to data science, which include business analysts, data analysts, or business intelligence engineering, where you wouldn't be focused on specifically coding and building machine learning models, but rather data management or data engineering as such. What I'll do is after this presentation, along with the PPT file, I'll send a document to the group which details specific roles that are available. And then yeah, you could read through that and discuss more. So then the last question that we'll consider, can you please define what is predictive analytics and what is its importance? So the idea here is that basically being able to predict tasks, the future based on historical data is the fundamental idea here. One simple example would be within Amazon, we've got a lot of sales data that is available per product. So for example, the iPhone, we have data for it for the last 12 months and other versions of the iPhone. If we are able to use this information and predict what the sales for the next 6 months would be, that will help us take better decisions in terms of what inventory we should have, how many iPhones we should have ready and available for customers to purchase. So the idea is being able to predict growth as well as other outcome variables based on historical data, and then using it for taking decisions is how it's going to be important. So with that, let's put a pause on it and then pick up questions from Musa and continue our presentation. So I'm glad to see the involvement. Thank you, guys. Now with that, let me just minimize this and get back to the presentation itself. So like Majid was asking, basically, how do we apply data science? We are going to get into that, which is the applications of data science. And let's start with the most pertinent one that we all are facing today, which is COVID-19 cases and death projections. So healthcare organizations or government organizations who are trying to predict basically lockdowns or want to understand what healthcare resources that they should provide or make available, they are working with biostatisticians and epidemiologists to basically predict what would be the total number of cases and unfortunate deaths that are happening due to COVID-19. So what you see here is basically a chart that shows the number of deaths in the United States over the last 6 to 8 months. And then what they're doing is they're projecting out what it would be over the next 4 to 5 months, along with what would happen if individuals wore masks. So these are other factors that they could predict on. They see a slight lowering of deaths. The worst case condition is significantly higher. So what you see here is an application of data science where we are doing forecasting using a machine learning model on historical data to predict future trends. So the next example, which I'm sure most of you must have seen, or some of you must have seen who follow sports or cricket, is what you see on the left-hand side, which is the ball tracking technology that exists not in sports, not only in cricket, but also in other sports like tennis as well. So what you see here is the prediction of where the ball would hit the wickets using you will also, if you'd like to, as a student, want to build a tool that is able to do that, there are projects and resources available online for you to build this out yourself. Another important and very common application that you all must know is transportation, which is what is the most optimal path that could be used by a package delivery company. So Flipkart or Amazon, if they're delivering their packages, their drivers have a set of predictions that say that this is the most optimal path that you could take, along with even within the maps that you use in Uber or Ola taxi cabs, it predicts which path that you could take for reaching the destination most uh, quickly. So this is an application in transportation. Moving on, government and politics. These days, a lot of government. So if you guys are tweeting, posting your opinions online, a lot of it is being gathered and being processed to understand what the public sentiment is, and sometimes it drives policies, etc. So what you see here on the left side is a couple of tweets that say whether the government is doing a fantastic job, which is a positive opinion, an okay job, which is a neutral opinion, and then the service has been terrible, which is a negative opinion. And this is used to aggregate and understand how people are thinking right now. So this is an application of data science for government. Moving on, in the entertainment sector, we have recommendations that you'd observe for on your YouTube page or Netflix page. So what you see here is a food video that's being viewed. And then on the right-hand side, you see a whole bunch of recommendations that are being generated. And how does this happen? The companies basically, they use your viewing history to understand what sort of viewer are you, and then try to find similar users as well. And then use that information to predict what is the video that you'd most likely see. And this is the same thing in Netflix as well, or other streaming services that you might consume. The data is being used to make predictions and to drive further viewing of their products. Next one, which is e-commerce. And along with stuff like product recommendations, they also have product classification. So what you see here are two t-shirts that might have been onboarded on Amazon. One is a cat t-shirt, another one is a duck t-shirt. And without having an individual human be able to look at these images, these models are able to process the image and then predict it. So the idea here is that we're trying to minimize the number of manual interventions that happen. If we did not have this model, every day you have a million products that are being onboarded. Just think of the of products are based on their image, using image classification, image processing, as well as machine learning, and extract that information out in the form of data and then be able to make predictions on it. So it reduces the number of manual interventions that you have to do. So now what we're going to do is let's do an interactive session, and I want folks in the chat to respond here. This is basically an application of e-commerce for product recommendations. What you see here on the left side is a set of users from 1 to 10, and then a set of items from 1 to 8. I'd like you guys to look at this and try to find the two users who are the most similar. And then using that information, we could predict what other product that we could recommend. So I'll give you guys maybe 30 seconds. Just look at this and try to find which two users have same ratings for products or similar ratings. And add your comment in chat. Great. So yeah, I see a whole bunch of folks saying 1 and 7, and that is absolutely correct. So this shows that you've got two users who've got very similar ratings, 5 and 5, 2 and 2, 3 and 3, 4 and 4, 5 and 5. Now, what this helps us with is that the similar user rated item 3 as 5. and therefore prefers this product. And now we could use this to predict to user 7. This is kind of how recommendation systems work in a very simple way, but with a lot more data. So it's good to see a lot of you guys participating and adding the responses in chat. Now, moving on to our second set of questions. So let's get back to where we were with Musa. Please tell us a brief roadmap in order to land a job in data science right from basic. Yes, Musa, we're going to get into the whole workflow that you need and the skills that you need, along with where you could get them. Right from fundamentally not knowing anything to becoming an intermediate expert and eventually growing to become a solid data scientist. So moving on to the question by Ramesh, I have heard that mathematics plays a very important role in data science. What are your comments on this? Yes, so we are going to get into the skills pertaining to data science. It has three important areas, one of which would be mathematics and statistics. It is important to understand the fundamentals of what algorithms that you're working with, but one simple point to note is that in terms of application, when you're building a project, a lot of the times those equations as well as the math part is condensed to a library. And then what you'd have to do is you, most often than not, you import that library and then run the model. It's good to know the mathematics because it'll help you grow as a very good data scientist. But in order to get started, you do not need to know it thoroughly. What you need to know is being able to understand what the algorithm is doing on a fundamental level, and then being able to apply it. And then as you start applying it, you could start getting into the math and developing a skill towards it. We have a course that comes down the line, a couple of courses, which I'll share with you guys that you could use to learn better. Is machine learning more like fixed algorithms just to put in data and get required results? Machine learning is basically letting the computer learn and develop those algorithms. When we're applying it for data science, we use those fixed algorithms and push in the data. Most folks in the industry, what they'd be doing is they're using these algorithms to push the data to get a specific result. There are opportunities to further enhance these libraries as well as improve the techniques that you use or combine a set of algorithms to develop a better machine learning model. So I would say to get started, the path would be to learn these algorithms and how to apply them. But as time passes, you learn how to efficiently apply them or even enhance them as and when needed based on your skill set. But for now, as a student in third and fourth year, I would say just focus on being able to build an application which is taking some data, putting it through a machine learning model, generating some results, and being able to interpret it. Is DL4J better than Python's libraries? I would say it is dependent on your preference. There are a whole ton of Python libraries that are available for you to be able to use. So I would personally recommend using, starting with the simple scikit-learn, XGBoost libraries, a whole bunch of libraries, which we will be discussing a bit in the future. Looks like my screen sharing ended. Let me just go ahead and start again. Is my screen visible?
Yes, is it visible?
Great. So, and great responses by Mushtaba Bhai as well. What are the basic things that you need to learn? We will be covering some of these topics that you could get started with. Shafiq, what is so special about data science that separates it from other fields? Like I think it mentioned over the last 5 years, 90% of our data has been generated. there's a lot of data that's being generated every day, and companies, governments, or industries, universities, academicians, everybody is interested in learning from this data to be able to predict things better. And because this is applicable to various fields, which is why it's emerging quite a bit, like across various fields, and you hear a lot about it. So creativity and development. So there is a bit of creativity as well as development, as in developing models, but the creative part is definitely there. You need to think of creative ways in which you could apply your data to these specific machine learning models. Apart from pandas, NumPy, Matplotlib, I will take this last question and then continue to the presentation. So apart from Python,
was just one, sorry to interrupt. I think some of these questions have been answered by Mustafa. So in the interest of time, maybe you can let Mustafa Hussain, read out or point out the questions that have yet not been answered. That way we can sort of move
efficiently through things. Yes. So what I'll do is I'll just answer this final one and then move ahead with the presentation. Apart from Python libraries like Panda, NumPy, and Matplotlib, there are a whole ton of other libraries that are available. I would say scikit-learn and XGBoost are two libraries that you should consider. So with that, let's move on to the next part of the presentation, which is skills that are needed to become a data scientist. And what you see here is an interesting Venn diagram where there are three specific areas which are the most pertinent and important, which include domain expertise, programming and databases, and then mathematics and statistics. So based on some of the questions in the past, mathematics and statistics does play an important role in the skills that are required. And at the intersection of mathematics and programming, you see machine learning. At the intersection of programming and data domain expertise, you see data processing. At the intersection of statistics and domain expertise, you see statistical analysis. And the intersection of all is where you see data science. So knowing each of these three areas, of which we will go into a little more detail, is going to be useful. So moving on, the first thing, which is programming and databases, I'd say to get started, the most important things in this area would be to be able to do SQL, which is structured query language. And some of you folks who are in CS and IT in your third year must have done already the databases course. So to query, transform, and load data. Along with that, you could pick up one of these two, which is either programming in R or programming in Python. When it comes to programming in R, I'd say it's important because it helps with statistical analysis. It's very quick to pick and easy to pick. You could do a whole ton of visualizations as well. When it comes to programming in Python, it's a lot more efficient with very larger data sets, and it's a lot more popular in the ML ecosystem. So if you want to get started, you could get started with R or Python and be able to work effectively. I would say choose one of the two based on your preference and then go ahead and get started. Moving on, the next important thing, which is domain expertise, which is an important part of this equation, which includes basically how do you translate what the business is looking for into some sort of data question. And one very simple question would be, within Amazon, we've got product managers who come and ask us which customers will generate the most sales or which product will generate the most sales. And the way that we go ahead by doing this is being able to determine what's the right data set to work with, and then figuring out what's the right statistical analysis or machine learning model to run. And along with that, a very integral part that you'll need, which is being able to communicate, is even more essential in machine learning because you're interacting with different audiences. You're interacting with other data scientists, you're interacting with other analysts, you're interacting with leadership, you're interacting with senior leadership. Being able to convey the same information in different ways and making it as simple and digestible for senior leadership as well is going to be important. So these are the two important parts. One is being able to understand the business and then being able to communicate your model effectively. So moving on, the third part, which is mathematics and statistics. What's important is that you understand what are the various machine learning algorithms, the libraries and techniques that are available. And here are some just names that are listed here, all of which you may not know, which is absolutely fine. I would say just you'll learn each of these in the courses that I'm going to be recommending. So what type of algorithm to apply, which could be a linear regression, a clustering algorithm, what sort of technique, which could be supervised or unsupervised, or libraries to consider, which is XGBoost, sklearn, etc. And then the fundamental math behind these machine learning data science approaches. So you could spend some time understanding how exactly is this model able to predict this? What is the core equation? At the end of the day, it comes down to one equation or a couple of set of equations that are being used and statistical techniques to consider. So with that, I remember one of the questions was how to get started. I would say you could use this sequence as well to get started, and we'll go into a few courses that are available in the upcoming section. So I'd say statistics, programming, which could be R and Python, and then databases, which you might have already done, which is data extraction, transformation, and loading. And then the next phase is exploratory data analysis, which is being able to explore the data, pre-process it, and try to find some trends within the data. And then moving on to machine learning, which is learning those algorithms and libraries, and then big data processing. So once you are able to build out models with smaller data sets, you'd want to start proceeding to build it with larger data sets. That is where Hadoop and Spark, which are frameworks that are effective for larger data sets, you could go ahead and use that. And then once you've built things out, if you'd like to visualize the output that you've built or the model that you've built or the data that's available, you could use data visualization tools such as Tableau, QuickSight, and then finally being able to document your results, which include the model itself as well as the results pertaining to the model. So just to reiterate, statistics, programming, databases, exploratory data analysis, machine learning, big data processing, data visualization, and documentation. So with that, let's take another break to look at a set of questions. And I'm glad to see a whole lot of questions coming in. So yeah, as Professor Ansari mentioned, let's try to find the ones that Mustafa Bhai hasn't answered or detailed and try to pick those one out so that I can figure ones out.
I think we are up to date, Owais.
Great.
Let's see if there are more questions.
So, I got a couple of direct messages as well. What I could do is I'll pick them up. So a question on best courses that are available for data science available. What I'm going to do is I'm going to get into that and you'd be able to figure out the specific courses that you could take. Another question that came in is, what is the difference between data analyst, data scientist, and data engineer? So to put it very simply, a data analyst is somebody who works with historical data. So they're just aggregating past data to find trends. Data scientist is somebody who takes that past data and makes projections for the future. And data engineer is somebody who helps both of them get that data. So just to repeat, data analyst is somebody who looks at past data to find trends. A good example could be, what was the most selling product in 2020? So the data analyst could go and ask the data engineer for that data. The data engineer provides that data. The data analyst aggregates that and goes back to the leadership to say that iPhone was the highest selling product. The next one is data scientist. A question would be, which product is going to sell the most in the next 6 months? So they take the past data, apply a machine learning model, and then make that projection. And the data engineer is somebody who's providing both data to it. So great. So great responses by Mujtaba Bhai. Thank you so much for helping out. So another question is on courses that is already been discussed. And thank you, Professor Ansari, for chiming in as well on the technique called collaborative filtering. Syed Mustafa, so how many months are required to learn data science and make a project? I would say you could start with the absolute fundamentals and do a couple of courses that I'll be recommending right in the next part of our lecture. And you could definitely, once you're done with those courses, be able to start building out very, very simple models in a month or two. However, in order to learn better, I would say invest at least 6 months to be able to build effective models, but you could get started very, very quickly. Let's take a couple of more questions and then move into the next part. I think these two, sir, a data analyst works is data processing, exploratory data analysis. Exactly correct. So Shahir, they do the pre-processing work, exploratory data analysis, and then the data scientist works on the prediction. And the last question before we move on to the next part of the session, can one get a job in data science after engineering, or is master's required? So this depends on the path that you take. And we have a session that's going to come up in a few weeks, which is going to be interviewing for data science positions, and where we will detail what are the journeys that you could take, including whether you need a bachelor's and how you could become a data scientist from your bachelor's degree, or how you could do it from your master's degree. There are different paths. You could definitely become a data scientist from just your bachelor's degree as well. However, the journey will require you to start as a business intelligence engineer or in a different role, and then gradually gain those skills and then transition. So it might take you some time to get there. For masters, your journey might be a lot more simpler, where you've done your masters and then start right away as a data scientist. So that's a very simple way to put it. So with that, let's get back into the presentation and look at the final section, which is how to get started. A lot of you have asked this question. I think it's important. And then we'll break out into a discussion, and I'll answer the remaining questions, ones that Mujtaba Bhai hasn't answered yet. So with that, the first course that I would recommend, since a lot of you are engineering students or a CS, IT, EEE, ECE, and you're comfortable with a little bit of programming, you've done it a bit. Before you get into core machine learning, you could start by doing this course, which is Python for Data Science, AI, and Development, which is available on Coursera, is being presented by IBM. What they'll do is help you learn Python to be able to set yourself up for data science. So including how to put it in a data frame, what sort of libraries that you could use, as well as how you could transform the data into from one format to another, and we have it ready for a machine learning model to pick up. So this, I would recommend, should be your first course. The next one, if you are interested in R programming rather than Python, then this is something that you could do, which is Data Science Foundations using R, which is a course on Coursera. presented by Johns Hopkins University. And this will provide you the same concepts, but in R, which is how do you load data, transform it, and get it ready for data science, and how do you start applying it? Another important part, which is SQL for data science. This will help you to be able to query databases in order to set them up for machine learning models. If you are in CS and IT, you've already done SQL a bit, so should be fairly familiar. But if you aren't in CS and IT in different fields, you could pick this up and it'll be a useful course for you to understand how a lot of companies work with data. Like in Amazon, for example, if you have to be a data scientist, you need to know SQL because the data sets are very large and SQL helps them be transformed into smaller sections. So among the three courses that I've described, Python, R, and SQL, pick two, Python or SQL, R or SQL, and you should be able to get started with programming and in SQL. And this course is also on Coursera. It's available for free. All these courses that I'm mentioning are available for free, so you could enroll, audit them, and then you could add it to your resume as well. And this is presented by the University of California at Davis. So once you're done with the programming part of things, you start getting into what's the fundamental foundation that you need to set up to be a good data scientist, which is basic statistics. And this is another Coursera course, which is presented by the University of Amsterdam, which will work through simple statistics that will help you be able to work on the basic mathematics or statistics that are required for you to get started with machine learning. And then once you've done all of these courses, this is the machine learning course offered by Stanford University, Andrew Ng. I've done this course when a few years ago as well when I was getting started. It's a Coursera course. It's still relevant to this date. I would say you should definitely do this course. It will cover basic machine learning concepts as well as algorithms and techniques that you could apply before you get started. So these 5 courses, do 4 of them. And along with working on some Kaggle projects, which I mentioned earlier, will help you get acquainted with this field. And then from there on, we will continue to share with you guys resources that you could pick up in order to become an effective data scientist. So what are the libraries? So somebody in the past was asking, so what are the libraries that are sort of explored in our ecosystem? Could be Dipler, ggplot, Tibble, Shiny. For Panda ecosystem, the tool that you use is Jupyter. And for Python ecosystem, the tool that you use would be environment that you would use is Jupyter, and the libraries that will be explored is Pandas, Plotly, Dash, as well as other libraries that are considered. So if all of these names are looking new to you, that's absolutely fine. These things will be covered in these courses and you'll pick them up as time passes. So what are the techniques sort of explored in these courses, which is supervised learning and unsupervised learning? And to put it very simply, supervised learning is basically building models using historical data. Unsupervised learning is like building a model without any training. You're just providing it data right away for it to start predicting and learning. So there are various applications of it, which include like regression, which is sales forecasting, logistic regression, which could be image classification. You've got clustering, which is combining various groups based on images as well. Image clustering, natural language processing, which we looked earlier, topic modeling for text, and then an exercise that we did, which was collaborative filtering and matrix factorization and product recommendations. The last point is the exercise that we did where we looked at users and items. That's a simple example of collaborative filtering. So these techniques as well will be explored in those courses, and you'll get a lot more familiar with them. So with that, moving on to sort of free compute resources, you guys are students. We don't want you to be paying for a whole bunch of things in order to learn. What you should be aware of is that there are free sources or resources available, such as Microsoft Azure Notebooks, Google Colab, where you could get started by just building out notebooks, importing your data, and start building your machine learning models. So take a note of these two resources, and you should be able to use them without having to spend anything. So with that, we are going to head into the final set of questions. And for this part, I would say, let's try to make this interactive, and you could raise your hand and open audio as well and ask a question, and we could have a conversation around that too. So let's get back to the questions that Mustafa hasn't covered yet. What are some good free resources? Professor Ansari has responded to that. How many months are required to learn data science and make a project? This I think I answered already. If you could please recommend courses. Dania's question has been responded. There's a question on a documentary. How these big companies are using data to learn, observe, compare, analysis, and control all the data streams and use it for its own benefits. So I would say a whole bunch of questions from Danish regarding why it is on the internet. A lot of the times is being used. Now, what is a good usage of data could be like if you are buying a product and it's recommending you a product, it's good. However, if you are providing a whole lot of text data, just be aware that on social media, a lot of it is being processed, and be careful about what you sort of share on the internet, because it is going to be used in various ways. Data is sort of the currency of the future. There are companies who are continuously monetizing it. Along with how important this is, I'm still an advocate of sort of data privacy. So be careful of how and where you share data, but along with that, try to build out these solutions in the most ethical way so that you could use the data in the most ethical manner to make life easier. A good example could be like cancer treatment and tumor detection is being built out using machine learning, where and image processing, which is a good usage of the data. Another one is political organizations using your text data in order to bucketize you and then specifically provide you news articles and ads. So that's a bad usage of the data. So it is dependent on how it's being used, and try to use it and in the most ethical way. So question by Shahir Ahmad, can you suggest some good laptop for the project? I would say instead of buying a laptop, if it's available, there are a whole ton of compute resources that are available online where you could spin a cluster, including the Google Colab and Microsoft Azure. All you need is to be able to open a browser and connect to the internet, and you could spin an AWS cluster or an Azure cluster and then be able to run however large a project that you need without having to run it on your laptop. That's the way that I would suggest it. So here, please repeat the names of the courses that I missed. One, let me just go back and walk through them again very quickly. So first one is Python programming. I will also share this presentation in the WhatsApp group as well as via email. So you will have it available to use. And then R programming, data science foundations using R SQL for data science, basic statistics, machine learning. So I hope you were able to get that, Shahir. Now, let me, great, thanks. So looks like we are near the end of the questions. And with that, what I'll do is, let me just show you this chart. So I'd like to say good luck to all of you to get started. Don't be this guy. Don't try to directly jump to data science. I would say take each step as you can, and that will help you eventually become easier for us to interact as well. And I'm on video. We could invite Mustafa Bhai or Professor Ansari as well. And for the next 5 to 10 minutes, or we could just open up the forum. I'd like to hear from you guys what sort of questions that you guys have, and we could take them up and answer them. This is an opportunity for you to interact with our mentors and learn from us. So let's see if you guys have any questions. I have. Can you tell your journey about how you became a data scientist? I think this is very relevant. What I'll do is I'll share mine, and I think even Mustafa Bhai, you could share yours as well. So it'll help them get some perspective on how we became data scientists. So to start with, my journey, I completed my bachelor's in computer science from Mufakhamjar College back in 2014. I was interested in data right from my third year. I was very interested in this data science course that further intrigued me. Along with that, Professor Ansari, you see, was my mentor back in the day. So he had guided me on courses that I could take. And what I did was during my fourth year, I worked on a whole bunch of data science projects. My final year project was a data science project. And I took the data science courses as well that were available on Coursera. And then I ended up getting a job at Deloitte for a year, which was in the data field. I worked on data engineering as well as data science projects. And then I wanted to further improve my skill set and go deeper into data science. So I then moved to the US to get a master's in computer science, but focused on artificial intelligence, machine learning, and databases, which I did for a year, and then got an internship at Amazon, which I eventually was fortunately able to translate to a full-time opportunity. And I've continued to work at Amazon since then, over the last 4 years as a data scientist. So that's my journey. I learned a bit in bachelor's, moved on to work, master's, and then finally to where I am today. And I think, where am I from? I'm from Hyderabad as well. So moving on to Mustafa Bhai, could you share your journey as a data scientist?
Sure, Wes. So I had a slightly different journey. In my engineering, I studied from the same college as Owais. I was a year senior to him, but very initially in my third year and fourth year, I was very interested in programming as such. I used to do a lot of mini projects related to Java, and then for backend, I used to use MySQL and all. So I was very much interested in a typical computer science role where you would want to do a lot of development and want to build applications, web or standalone. But when I actually got to the real world and I started my career with Accenture, where I was working as a software engineer, what I realized is that while working, I was more so inclined and more interested in solving problems using data. So I had a bit of background with software engineering that helped me in coding, but I enjoyed a lot working with data. So I started finding opportunities within the same org where I could work with data. And that's how I developed some basic skills. I went through the whole cycle of being an analyst to being a data engineer to being a data scientist. Over course, I moved on to another organization where I was consulting for operations. There was this pharmaceutical consulting firm, ZS Associates, where I worked with a lot of customers to get insights, create their reports, predict sales data for them. And over all these years, I've constantly been a a learner. I'm a strong advocate of online learning and MOOCs. I haven't done my formal masters, but I've done a bunch of courses. Like I would have at least completed 15 courses over time, and there are many more that I have enrolled, and I go to them as and when required. So yeah, I've been with Amazon, and I didn't start as a data scientist at Amazon. I started off as an analyst, but then over course learning and upskilling myself, I've come to a point where now I'm a data scientist in the AWS.
Thank you, Mustafa Bhai, for sharing that. And yes, as Mustafa Bhai mentioned, it's important that you continuously learn whatever phase within your life that you are. There are a whole ton of online courses available. Make the most use of it and try to improve yourself in whatever way you can. We all work on learning in our own ways. So that's a very important lesson for all of us. So can you suggest some advanced machine learning projects? I would say if you are a beginner, don't think about advanced machine learning projects because you might get stuck and disheartened and not be able to proceed further. What you want to be doing right now is start with the most simplest project that you could build and then gradually move yourself upwards. And let me just very quickly share my screen for Kaggle and just show you what this is. So what you see here is the website Kaggle, and what you could do is you could start with something like predicting house prices. And then another one is unfortunate one, which is predicting whether you'd survive if you were on the Titanic, survival on Titanic. So from there on, you could go into other competitions that are some of them are very complicated. And that would be the path that I would say. But start with something very simple. Do you have anything to add, Mr. Bhai, or you'd like to take another question?
I think that was a great advice. You start simple and build on top of it. Like the problem that Owais shared, the Titanic problem, there are thousands of solutions submitted to it, and there's always somebody who comes up with a better solution for it. So there's always scope for improvement, even in the simplest of problems. So pick a simple problem and try the best out of it.
Great. So then what's the importance of CGPA and proceeding in this field? I would say if you're going for a master's, then your GPA would be useful in trying to get to a good university. But along with that, what's most important would be to apply and build projects as well. So focus on your GPA, which is great, but along with that, try to diversify your skill set or resume, which could be projects, courses, other areas of interest that could help make you a well-rounded sort of application for a master's program. In terms of jobs, your CGPA wouldn't matter as much. If you have the skills, you could apply to a position if you crack the interview. It doesn't matter whether your GPA is 7 or 8, but it's more important to have the skills, but having good GPA is also useful. Next, you would say the same as well, right, Mustafa?
Absolutely.
Great. Would you suggest that we go for work for a year after bachelor's and directly go for master's? I would say work right away. This is my journey as well. I, after my bachelor's, worked for a year, and that helped me understand what I wanted to do. And it gives you a lot of perspective and helps you understand exactly what path that you'd like to take. So I'd say work for a year or two, and you'll realize what you want to do in life, and that'll help you. And then if you want to, you could go for a master's. Directly going from bachelor's to master's is, I wouldn't say, from my perspective, ideal, but it's up to you. So let's see if, so here's a question, Mustafa, if you want to pick up. I've been learning machine learning for 6 months. I made some basic projects and I want to move to the next level. Can you suggest some projects? I suppose so the Kaggle thing would fit, right? Did you want to elaborate on this?
Yeah, Kaggle does have multiple levels of problems that that you can try out, Hamad. I mean, right from basic to very advanced problems as well. It should be a good place to begin and compete as well.
Sure. Great. So then,
You
there
know,
are a
one
few
thing,
direct questions as well. Yes.
always one suggestion here, people can unmute and ask the question. This way, they'll be able to participate also. So
Perfect.
we
Yes,
are at the
that's
end
that's what I'm recommending as well. It would feel a lot better if some of you guys could join in and participate in the conversation. This is your opportunity to ask Professor Ansari as well as Mujtaba Bhai and other me as well. But
there are
still,
many other mentors also available here, so they
exactly.
can also chime in.
So I would say raise your hand and ask any question that you'd like to. Then what I'll do is, till then, I'll just look at the next question. Can I get some tips from you for cracking the interview? So in order to become a data scientist, you need to be comfortable with SQL, Python, or R. In the interview, there'll be one round where they'll ask you SQL, one round where they'll focus on sort of coding in Python. Then you'd have data science breadth and depth. So I would say follow the sequence of courses that we've recommended, go through them, and you'll be halfway there. But along with that, work on projects that will help you develop the skill set that is needed to be able to apply these machine learning models. And a lot of the times in these interviews, they ask you use cases and how you would sort of solve for them. And that will help you quite a bit. That's how I focused on interviewing as well. Sometimes they even give you some data and say that you should go ahead and make some projection. But that would be my recommendation for cracking the interview. Another one would be to apply to a whole bunch of companies and practice giving interviews.
So you guys, if you have any questions, why don't you unmute yourselves and ask? You don't even have to raise your hand. I mean, we want you to talk. So no point in putting it in the chat now. So just we'll wait a little bit. For those of you who are shy. So.
Yep.
Sam Kaniz has a question. Let her raise that.
Okay, Kaniz, can
Kaniz,
you
unmute and ask that question, Kaniz?
So what we'll do is, let me go ahead and answer that question for
I
somebody
think, wait,
who's new
Owais,
to the work.
that
Yes.
they should learn that habit. They should not be hesitant. Let her
Sure.
speak today. Kaniz, would love to hear from you, beta. Come on, get up.
Yes.
Great.
So I'm from EC, sir. Good morning.
Perfect.
Hello.
So yes, what is your question, Kaniz? Yes, we can hear you.
From EC. So how can you guide me? After this session, I am interested in this field. So how can I work towards this field?
Great question, Kaniz. So I would say if you are from EC as well, there are a lot of applications in your field too. There are many communications companies, electronics and communications, as well as CS companies who are looking for folks in various fields. And somebody who's coming from EC, you have the math that you're working in engineering, so your fundamentals would be there. What you need to do is focus on the statistics, machine learning algorithms, and developing your programming skills and doing a few projects, the combination of which will help you build your resume and then work on applying to specific companies. There is no barrier to entry here. As long as you have the right skills, it will help you get there. So that would be my recommendation. And I would say, I'll be sharing along with the presentation, a sequence of resources after this in the group, which will have additional courses as well as the links and a few books as well, and that you could pick up and start reading. And a few project suggestions as well, right from basics that you could start working on. So that would be my recommendation. Do you have anything to add, Mustafa bhai?
I think that's about it. It doesn't matter what background you're coming from. There are a lot of folks who are coming in from core engineering as well, from mechanical production engineering. It's the bent of mind that's tested out in most of these interviews, and a bit of hands-on experience with Python, R, SQL, whatever tools you're using. So it's a lot about how you approach these problems and have the basics right. And doing projects, like Owais said, is a great strategy to go in that direction.
I think
Great.
you will put it on the website too, Owais. On our
We have,
website,
we
on the
have a lot of
resources.
stuff on
We
the
have
website
a whole
already.
lot of resources on the website. I'll add this
Absolutely.
presentation as well.
Put the
And some
presentation
other
on our resources website.
We could certainly do that, Vishal bhai. So we can certainly put the presentation on the website. That would be useful.
Great.
Okay, I have something to add. This is for those of you who are not asking any questions. So I am from HR. So I can tell you from my experience, not just when you are being interviewed, but after you get onboarded into the organization and when you are put forward to work on a project, if you are not opening your mouth, let me tell you, you will be on something called bench, which means you will not get opportunities to work on projects, and companies can only look after the bench for a certain period of time. They will invest in your training, but if you don't open your mouth, then unfortunately there is a different treatment that will be applied. So I think this is a great opportunity for you all to practice, overcome that fear that you have of speaking, because here you are not even on a stage. I mean, you are not even opening your camera. All you have to do is just speak. So my only request is make use of these opportunities, because today or tomorrow you have to speak.
I think that's great advice. So I'm waiting for the next question then.
Great. We've got a few private questions by Danish. If you want to, you can open it up to the group as well. If you could go ahead. I think that would be
Otherwise, I think we should encourage everyone to ask questions.
Yes.
I think, you know.
Am I audible?
Yeah.
Yes. Great.
So I had this question: does data science give us opportunity to work remotely? Like being a girl, like not staying back at home, but at some point, if I stay back at home, can I work as a freelancer?
So there are many companies right now who are transitioning to fully remote. Even within opportunities in Amazon, Microsoft, Facebook, Google, and there are, if you just go to naukri.com, monster.com or indeed.com and then search for data science and then filter on remote working, it'll open up a whole ton of job positions. This is something that where you will have communication that's required, but that can be done over calls. I actually work remotely right now, both due to the pandemic, so it's definitely possible. So I would say you could look into those. Does that answer your question?
Thank you. Yes, thank you.
No worries. Great.
Just to add to that, Owais, I think, Zohar, for your question, today, 98% of the workforce in any multinational organization is working remotely.
Yes, yes.
So absolutely possible.
Yes, thank you, sir.
This is another aspect that Zuha asked was, can she work as a freelancer as well? Yes, there are a lot of opportunities for freelancers as well. There are many companies, there are many startups, or for that matter, firms that are helping these out. There are websites like Upwork, or there are websites like Crossroads, where you can actually enroll or join as a freelancer, do some projects, demonstrate your work, and then you would actually be working directly with the client without any anybody in the middle. So those are some great opportunities for somebody who'd want to work remotely.
Yes, thank you, sir.
Any other questions?
Sir, what is the difference between artificial intelligence and machine learning? Because people make them look as the same field. So And just I want to know, is there any difference? Are they same or?
I would say basically artificial intelligence is sort of the parent name for a lot of these subdivisions within what is available, one of which is machine learning. And machine learning is basically what we're doing is if there is some sort of decision that you'd like to automate, you'd like to predict for, and you want the computer to be able to do that for you, you can use machine learning algorithms that are available today in order to pass that data for it to learn from that and make predictions for you. And that is where particularly machine learning fits in. But beyond that, artificial intelligence could have a whole bunch of other things, which include things like robotics, which has not just software, but also hardware components associated with it. You've got to program it and be able to have image processing, computer vision, applying machine learning algorithms, as well as working on the hardware aspect of it, which would fit in artificial intelligence. So I would say, don't worry about the semantics. Focus on getting the fundamentals right. Focus on the basic statistics, machine learning algorithms, and then if you are from EC, there are opportunities for robotics as well. So you could focus on things like computer vision, image processing, programming, hardware, etc. And just pick your field and then work hard to gain those skills. So that would be my response. Danish, I see that your hand is raised. Do you have a question?
Hi everyone. Owais. Am I audible?
Yeah, you are.
Yes, you're audible.
Yeah, actually my question was, do we need to know AWS or Google Cloud Platform or Apache before learning data science?
You could, if you want to, start by just working on Jupyter notebooks on your desktop by downloading Jupyter and then passing a data set that you have on your desktop and be able to develop your very simple machine learning model. However, if you'd like to scale it up, build a model that is using very large data sets, in that case, you need some sort of cloud computing resource. And for that, you would need AWS, Azure, or Google Colab as well. So it's a useful skill to have. Pick one of those, and then there are a ton of tutorials available that you could pick up to determine what cloud computing, how to use the cloud computing resource to build your models. Great. So next, I see we have a hand. Does that answer your question, Manish?
Yeah,
Of course. Thank you.
Yeah, I'll just add to that. So see, I think the company's expectations, or I think the technological advancement that is happening, it's changing pretty fast. So earlier, one person used to deal with only one particular technology and was a pro at that. But now the companies are expecting somebody to have not just, they call it a T scale, wherein you have a vertical depth and then the horizontal. And now they're talking about the pie structure, where you know one technology and parallel to that something else as well. Because back in the early 2000s, probably things were different, but the technology is changing at the drop of a hat now, and agility is something that every organization is expecting. So the more you know about other domains or other technology, it will only add to your entire profile.
Great. Thanks, Sajad Bhai, for that explanation. I see that Shafiq has his hand raised. Is that Shafiq, or was that somebody else?
Shafiq.
Yeah, good evening, sir.
Yeah.
Am I audible?
Yes, you're audible.
So basically, data leak happens so often nowadays. I remember in 2018, a social media website was accused of data leak in India. So what role data science plays to protect the sensitive data of the client?
So the role that we play is that we make sure that whenever we have customer information that's available, which we have very limited of, we usually do not have access to pretty much everything. We mask any personally identifiable information. So any information that is able to identify customers or individuals and how it's associated, that is encrypted and not allowed for even data scientists such as us to be able to use. For the broader question of data leaks, I would say it's important that organizations have stronger sort of cybersecurity departments which are ensuring that their customers' data is being secured effectively. And then on an individual employee basis, it's important that each and every one of us be cognizant of the fact that we're working with customer data and prevent it from being shared with anybody internally or externally who isn't authorized. So keep these principles in mind whenever you're working with data within an organization, but still you see data leaks happen, which are unfortunate. Mustafa bhai, you'd like to add something to that? Or
I think you covered it.
Yeah, so one aspect which probably, I don't know what the student really was looking for, but as a data scientist, you can also do intrusion detection in some sense. And so, you can try to sort of, analyze data to try to figure out whether this is an authorized user or whether somebody is intruding into systems. So that's another perspective that one could sort of, use. There are two other, hands raised. Maheen is here, Shahir is here. So.
Great. So yeah, let's go ahead with Maheen.
Yeah, Maheen first. Maheen,
and then
raise your hand
Shahir. Yeah, Maheen, could you go ahead with your
Good morning, afternoon, sir.
Thank you.
Good afternoon, sir. Am I audible?
Yeah.
Yes, you're audible.
Yeah. So, sir, I'm actually very interested in cybersecurity. In fact, I have been planning on doing my master's in cybersecurity. So, in that sense, what should I know about data science? I mean, what concepts should I know about data science that will help me in the future to pursue a job or opportunities in a cybersecurity field?
So I would say we have, I think, a mentor who is in this space. What we could do is, in this field in particular, I would say you would need some additional education. Along with your bachelor's, focus on doing online courses as well as seeing if you could pursue a master's degree. It's a very relevant field, a very important field. But what we could do is we'll figure out who our mentor, one of our mentor who works in this area, and get you some resources on cybersecurity in particular.
Okay, thank you, sir.
Great. Shahir, do you have a question?
Hello, sir. Hello, am I audible?
Yeah.
Yes.
Sir, actually, my question is that I have been I have started studying data science about some 7 to 8 months ago. And then after some time, sir, I have studied exploratory data analysis also. So almost after covering exploratory data analysis, all of those stuff. So I just thought that maybe I should get into my core subjects also. I'm a EC student actually. But sir, since a month ago, I mean almost from a month, I think I realized that I am really interested in coding. So and I'm good at that. So I was just trying to, like, I have Jupyter, I have done courses also, and I have Jupyter notebooks too saved on my laptop. So I was just thinking that I should probably go through the concepts again and then continue upon that. So my question is that I have learned exploratory data analysis, and so should I practice more upon that, or should I go for like exploratory data analysis is a data analyst's work. So should I continue my practice upon that and take up Kaggle data sets, and I have taken up 2 long ago. So should I continue practicing that, or should I like do more courses which you have suggested, like SQL and machine learning and all that?
I would say if you've done exploratory data analysis, then you should start working on the next step, which is predictions and machine learning. So you could do both the things simultaneously. You could start the courses that I've recommended. If you're comfortable with Python or SQL and programming in general, then you could start with the basic statistics and machine learning course. Along with that, pick up one simple application on Kaggle and then try to use your current skill set to solve one of that and work on the programming aspect of it. There's a lot of you will find a lot of usage of your programming skills on the competitions available in Kaggle. So that will be my recommendation in particular for you. If you're comfortable, yes.
One thing I just want to add here, which I think is very important, is that your soft skills have to be good as a data scientist. And so, irrespective of what you plan to do, that's one very, very important thing to sort of keep in mind. Especially as a data scientist, as Owais pointed out, you have to interact with people with different levels of technical expertise. And so my advice to everybody here, whether you in fact want to do data science or not, keep this in mind that your soft skills are tremendously important. So we are at 11:29 US, and I think it's time for us to wind up. If Motasam Saab is here, I think if you can just take a couple of minutes to explain a few things about the session tomorrow, Motasam bhai, that would be great.
Okay, thanks, Asim. So tomorrow, after this great session on data science, we will actually focus on what are the skills that you should acquire in order to be a great software developer, right? And that could include being a data scientist as well. This is a little more specialized, but we will talk in general. And similar to what we have done, we really want to make these sessions as interactive as possible. And today has been great. We'll follow a little different pattern. If you remember Dr. Razi's presentation on a learning mindset, I'm basically stealing that idea and modeling tomorrow's session exactly on that. So I'll give maybe a 30-35 minute pitch on all the different skills that if you diligently and faithfully acquire between now and when you graduate, then I'm pretty confident that you will have a great competitive edge in terms of your next step, which is getting a job in the company of your choice. So I'll do the pitch, and then we'll have breakout sessions. And a bunch of my colleagues, mentors have graciously volunteered to moderate this. We will discuss basically 3 different aspects of these skills. And all this information is in the invite. As well, I have shared some, fairly, small articles, but really to the point of the talk I'm going to give. It'll be great if you can read those articles, come prepared, and the way to evaluate the session is how well, not so much my presentation, but how well you read and come and have a robust discussion on these. That's how you're going to learn. There's difference between just passive listening to a presentation and actively actually participating. Your knowledge retention is always going to be greater when you are part of that discourse. So encourage you all to read those articles and come prepared. We will try and have a Q&A as we did here, but in case we run out of time, I promise you we will gather all your questions and follow up with answers, as well as a lot of resources that I will share with you all, because the topics are broad and it is impossible to cover each one of these in depth in a 30-minute presentation. So to overcome that, after the presentation, I will share with you a lot of resources, courses, articles, and books that you can read to follow up and hone those skills. So back to you, Asim.
Anything else that we want to cover? Otherwise, I think we are almost at the end.
Asim, Mubin Saab, I was thinking, Chad, Amreen will talk today, your mentee. But I think the session is over. I hope we will listen from Amreen tomorrow.
Yes, indeed. I hope so too.
Yes.
Great. With that, what I'd like to say is thank you, Professor Ansari, Mustafa Bhai, Sajjad Bhai, and for participating in the conversation, and the students as well for being interactive on chat as well as coming up and asking the questions. It's been a good session, and thank you for participating.
Great. So I think it's time to wind up now. So, we'll see you tomorrow, guys.